Hello and welcome to XMed Education. My name is Ali and I'm here with another video in the physiology of heart. I appreciate if you guys subscribe to my channel, like my videos and share it with your friends. So in this video we're gonna talk about the systole and diastole of the heart. We're gonna talk about the heart cycle, heart sound and pressure, volume, lobe. And in the end I'm gonna give you a brief summary of what we discussed. Let's start. Systole and diastole. Systolic is during the time that the heart contracting and diastolic during the time that the heart is relaxed. What do we mean by heart? We mean actually the ventricles, the one that they actually do the major job. So when is systole and when is diastole? We can detect them on two waves. First by ECG and second by cardiogram, which is auscultation, like the one we put the stethoscope and listen to the heart. ECG, on the ECG, we have QRS complex, which is the depolarization of the ventricle, and we have T wave, which is repolarization of the ventricle. The depolarization and repolarization is a systolic, and this means the contraction of the ventricle. So during this time, in another word, blood goes through the aorta, like blood from the ventricle goes to the aorta. And we have the diastolic part. Diastolic is from the end of the repolarization of the ventricle, end of the T wave, till the QRS complex, till the atrial contraction. And S1 to the S2 is the systolic. So I'm gonna talk about them, what they actually means. And S2 to S1 is diastolic. Diastolic is a bit longer than systolic. So let's talk about the cardiac cycle. For the cardiac cycle, we need to know about such a graph. And please, I encourage you guys to understand this graph and draw it for yourself for better understanding. In this graph, we need different things. The first one is the heart sound. The second one is ECG. Then we have the volume of the ventricle, and we have pressure in different parts. For example, we have ventricular pressure in blue color, we have atrial pressure in yellow color, and we have aortic pressure in the red color. So first let's start with the P wave. What's happening here? In the P wave, atrium start to depolarize and they cause the atrial contraction. So when the atrium, the muscle contract, the pressure inside the atrium goes up, and this rising in the pressure can cause the atrioventricular valve opening. Atrioventricular valve on the right side is tricuspid and on the left side is bicuspid or mitral valve. So the other thing that you need to know is that the aortic valve during this time is closed and the ventricular volume peaks during this time. Let's look at it in the graph. So P wave happening, atrial contraction happening, and when the atrial contraction, the blood from the atrium going to the ventricle. So as you see, there is a bit rise in the volume of the blood inside the ventricle, and this pressure that goes up is because the atrial contraction. So as you see, there is a bit increase in the pressure of the atrium and also ventricle as well, because because the valve is open. So there is a one physics note that you need to know. Everywhere that pressure goes, blood will go. So left ventricle pressure is lower than atrial pressure. That's why pressure from the atrium goes to ventricle, because the pressure of the atrium is higher than pressure of the ventricle at this time. Let's go to the QRS complex. So what's happening during the QRS complex? QRS complex is here. During this time, ventricular depolarization happening. When the ventricular depolarization happening, they actually send signals to the muscle of the ventricle to contract. So contraction just starts. When the contraction just starts, the pressure inside the ventricle start to goes up. So when they goes up, they become, the pressure inside the ventricle become more than the pressure inside the atrium. So mitral valve will close. So valve, actually mitral valve is like a door. They open this way, but they can't go like that way. So they close in such a position. So when the atrium pressure goes up, the blood goes in, but when the ventricular pressure goes up, the valve close, and closure, like closing a door, will make a sound. That's why we hear the first sound, like we hear the S1. During this time, there is an isovlomic contraction. What do I mean by isovlomic contraction? So we mentioned that the mitral valve is closed and aortic valve is closed as well. Why? Because the pressure is going up, but still it didn't reach a level to open the aorta. The pressure inside the aorta is very high compared to the heart, so we should have a huge pressure to open this valve. Just imagine a wall that some people are behind this valve, so we need very high pressure to like push all these people aside and enter the other room. Aorta is exactly like that. So isovlomic contraction, iso means like not changing, volumic means volume, so there is no change inside the volume. As you see here in the volume, there is no change in the volume, and we call this section as a end diastolic volume, because here is the end of the diastolic, and the most blood that is inside the ventricle is at this time end diastolic volume. So the pressure goes up, QRS complex happening, the pressure of the ventricle goes up till ejection is happening. So what is ejection? Ejection is from the opening of the aorta. So as we mentioned, ventricular muscles are contracting, and when the contraction force make a pressure more than the aortic pressure, and the aortic pressure that need to open the valve, which is 80 millimeter of the mercury, the aortic valve will be open and blood eject from the ventricle to the aorta, as you see here. And because of this pressure of the ventricle, the pressure inside the aorta and the pressure of the ventricle, they both goes up till 120, as you see here. So from 80 they go up until 120. This part count as a fast ejection part of the as ejection part of this ejection. So why is it fast? Because the ventricular muscle contracting and they make a huge force. This huge force causes the rapid ejection of the blood into the aorta, and then the contraction will decrease and blood slowly goes to the aorta. So as you see, like the slope here is higher than the slope here, so the blood goes with a faster speed than this part. So we have fast ejection, then slow ejection. And the other factor that you need to know about this part is that during the whole contraction, blood is coming to the atrium. From the lung, blood goes to the atrium to fill it and help to like fill it for the next contraction. So the atrial pressure goes up, as you see here. See, like there is a bit increase in the atrial pressure. So then aortic valve close. As I mentioned, aortic valve after this ventricular contraction ends, this aortic valve will be closed. But look, the closure is a bit above the opening pressure. Opening pressure is at 80 millimeter of the mercury, but the closure happening at the 100 millimeter of the mercury. There is a difference, and as you see, there is a slowly like this decline inside the pressure of the aorta. Why? Because of the elasticity of the aorta. This pressure goes slowly down. So during this time, there is a relaxation. There is no muscle contraction, so there is a relaxation. And as we mentioned, the aortic valve is closed at this time, and mitral valve is still closed. Why? Because still the pressure is high. The pressure should be very, very low, like something close to zero, to let the mitral valve open and blood comes from the atrium to the ventricle. So during this time we have isovolumic relaxation. Let's go. The next part is the fast filling phase of the ventricles. So during the diastole, this part is the diastolic time. And another factor that I need to mention here is the end systolic volume. So remember, if you forget everything from the cardiac cycle, you should never forget two things. End diastolic volume is the highest amount of the blood inside the ventricle, and systolic volume is the lowest amount of the blood inside the ventricle. The highest amount is around 120 milliliter, and the lowest level is around the 50 milliliter. It means that at the end of the contraction of the ventricle and at the end of the systole, still there is 50 milliliter of the blood inside the ventricles. And now let's go about talk about the diastole. So as I mentioned, during the systole, blood was filling the atrium, and when this isovolumic relaxation ends, the mitral valve will be open, and when the mitral valve open, the blood goes from the atrial to the ventricle, but there is no need for contraction. The pressure just coming down, and blood will just go inside the ventricle without any contraction. Contraction happen after P wave. See, like here contraction is happening, and this is only 10 to 20% of the heart ventricular volume. So in case that atrial doesn't work, this atrium, if they doesn't work properly, for example, there is a condition called atrial fibrillation, where the contraction of the atrium doesn't happen regularly and they have a problem. So in this, when there is such a problem, feeling of the heart does not have any problem, because 80% of the ventricle will be filled and it's enough to send it to the aorta, but they can make other problem that you guys gonna study in pathology. And heart sound. So we have S1. S1 is the loudest one. Why is it loudest one? Because these two valves, mitral valve and tricuspid valve, will be closed, and they close by the pressure of the ventricle. So this pressure is really high, so it's normal that we have this loudest sound. This happening during the isovolumic contraction. The S2 happened during in the beginning of the isovolumic relaxation, and it's because of the closure of the aortic valve. As you remember, the closure of the aortic valve was at the 100 millimeter of the mercury. S3 and S4 typically does not hear. Why? Because they are mostly pathological. S4 is definitely pathological, so if we hear S4 is definitely pathological, but if we hear S3, it can be physiological in some people. For example, in the athlete, we can hear the S3 because they have a stronger heart muscle to pump blood through the muscles. And as you see, S3 is close to the S2 and S4 is close to the S1. That's all you need to know here. Let's go. Pressure volume loop. Guys, this loop is really important. You have to know from the basic and all the pathology that happen. For example, if there is any disease with the valve, if there is any disease with the pumping blood inside the heart, this pressure volume loop will change and you have to know it. In our next video, we're gonna talk about details in this pressure volume loop. So first, let's begin with this loop. What is this? Here is the lowest level of the volume inside the ventricle. So when the volume is the lowest, what is it? It's end systolic volume. And when the end systolic volume is happening, mitral valve will be open. Mitral valve will be open, and blood from the atrium atrium goes to the ventricle, and they fill the ventricle, and at this time mitral valve will be closed. This is 120 milliliter, and here the valve is closed, and at this time aortic valve will be open. Aortic valve will be open at 80. So when is it? It's when the aorta will be open. So what we call this part, we call it isovolumic contraction. Why? Because the volume is constant but the pressure is rising. At the 80, aortic valve will be open, fast ejection, slow ejection, isovolomic relaxation because the volume is same and systolic volume. And aortic valve will be closed and mitral valve is closed all this time till here that the mitral valve will be open and the next lobe is happening. The lobe is actually from this side to this side, and I explain everything about this lobe. So in this video we talked about the heart sound, we talked about the heart cycle, we talked about the pressure volume lobe, and we discussed all of them in details. Thank you very much. And in the end, I want to say that 90% of the winning is inside your mind. Remind yourself that you've got this and encourage yourself to stay on a track. Thank you very much for watching my video. I wish you guys all the best. Please subscribe to XMed Education, like my video, write a comment for me, and this definitely helped me to improve my videos and encourage me to make more.